Okay, there we go. Get us started. I think you guys did really good on that test. Let's take a look. There was a couple of questions that we need to clarify. I think that you did really good on this one. It says 8 people got it, and this question talks about select case statements, which we can't do in Python. I have a hard time with things like this. I do a lot better with the stuff that I can actually practice hands-on. So really good job getting that, as many people getting it right as did, because, but yes, we could have both of those within a single loop. Any of these type questions, they're usually, yes, you can, because most of them, they're asking you weird things like, can you have 2 loops within a loop? Sure you can. All right. This next one again, everybody did really good. It is not possible to put a loop inside an if-then statement. That's false. We can do it. It is like a double, triple negative, but everybody figured it out, so good job. This one, everybody got really good. If number equals 4, is the following statement true or false? Int number times number equals number times number. So good job. That seems easy to you guys now, obviously, since 9 of you just got it right without even thinking about it. But a few weeks ago, that was not that easy because we had some questions like that on that previous test that threw some people. So good job. Now let's look at this one. These ceiling and floor ones, this can be a booger. Ceiling always goes up, not round. It doesn't go round. It just goes up. So ceiling, so that's actually true. It's a weird command. It really is a weird function. We think more of rounding. That makes more sense to us than the ceiling function. So just remember, it always goes up. So if there's any decimal place at all, it's going to go up. Now this one is rough because it was a fill in the blank. So I've graded these manually. So if somebody had some other word there, I would catch it. But they do tell you what they're looking for before or after here. And so our outer loop is always going to be the one that starts first and ends last, because it's the one that's controlling the whole thing. So lots of code there. Everybody got it because it had stars and things like we were working on. So good. And then another long one. Everybody's doing really good on these hands-on ones. That's great. And that's kind of how it is. There's always those 2 sides, the hands-on side and the terminology and getting the test questions right side, which can be tough. So just think about working on a car. A mechanic can be the best mechanic ever in the world, but sometimes they have to step back and take a test. So that can be hard. All right, here we're looking at our random numbers, and what the chapter is actually looking for here was pseudo-random. And I took a lot of things here like random numbers, random values. They're really looking for pseudo-random because remember, it's not truly random because there is that seed value. So if you read through that little section in our textbook, they do a really good job of explaining how those random numbers are generated. Good, good, good. There were only 4 people that got this question, so take a look at it because you probably didn't. It says, my number is 7.82, so what's the value of this math statement? What's going to happen first?
Divide by 2.
Divide by 2. What are we going to get there?
3 on.
You're going to get 3.
Just 3? Just 3?
You do the
Yeah, since our 2 is an integer there. And then we'll add our 0.5 to get us this 3.5. So that integer division can always get us. Okay, in this one we add about half. And again, it's a fill in the blank and it's kind of open-ended on what we want there. Some of you might have filled it in giving me Python syntax. Some people might have filled it in just giving me pseudocode syntax. Other people might have just said like +5. I took all of those because that's what we're up against here in our class. All of those things are what we're using. So that's what it wants to know. Oh, wait, this one is talking about the test condition. So whenever we're talking about the test condition, we would be looking at my count less than or equal to 20. Because that would be our condition on that one, right? So some people gave an answer of like +5 or whatever. So watch closely because the test condition is that comparison part. And then
So that would have been my condition +5. I mean, my count +5, is that what you're saying?
no, it wanted the condition. So it would be my count less than or equal to 20.
Oh, okay.
Do you see that?
Sorry, yeah.
No, that's what I wanted you to notice. Because yeah, it asked you a lot for how it would be incremented. I don't know why. I think some of the questions show up more often than others. I don't think this one shows up very often. A counter in a loop can count up by 5s. Sure it can. We just add 5 or put 5 as our value. And then another true false one about integers. Oh, and you guys just did great on these questions about the random numbers. How does this work? Well, remember our random number is a value between 0 and 1, a decimal number. So if we take that truly random number from other programming languages, it's a decimal, and we multiply it by 4, then we're going to be able to get, 0, 1, 2, 3 as a value. In this case, they add a little bit of complexity to it and say, plus, we're going to add the number 3 to it. So then we're looking at 3, 4, 5, and 6. And these are really good ones to try with Python, just to mess with them and do some trying with things. Widgets is an integer value. This is hard to read, so good job. So we're saying while widgets is, an integer truncation of widgets is not equal widgets itself, we prompt them to enter a value and input the value again. We'll do that repeatedly in our while loop. The function that converts a number x to a corresponding string is what is that one? You hear from the back. I'm not hearing it. Thank you. Now, a lot of people got that one wrong, and that one I don't see any reason for getting wrong. If you got that one wrong, you need to go look, see if you got it wrong. We've used that in almost every Python program we've written. So if you got that wrong, you need to have a little talk with yourself to figure out why. Is it because you're not paying attention? Like now when I asked you what that function was? Is that what it is? Or is it because when you look at a test question and you have to fill in a blank, you have a panic attack and your brain won't let you think anymore? Because if that's what it is, you can get some help for test anxiety at the counseling center because you need to get over that because you're going to have a whole lot more tests coming up. So I want you to really think about that with this question. if you got it wrong. Why? Why did you get this one wrong? Because this one is not one. Is it the way it's worded? That makes sense. Did you not give yourself the best opportunity by not taking the practice exam? When you took the practice exam, did you not, again, give yourself the best opportunity by going to the textbook or going to sample code that we've written and looking things up that you weren't sure about? Make sure that you're doing all of these things to give yourself the optimum opportunity. This one, beautiful, really hard, and everybody gets it. Okay, so on this one, we've got some statements here, and we have our subprogram named lunch. This is our function, and it's being passed these parameters, sandwich, side, and drink. And when we call lunch here, we're passing soda, chips, and burger. And it wants to know which of those arguments are going to be passed to which parameter. So our soda is going to be passed in as our sandwich. Our chips would be passed in as our side, and our burger would be passed in as our drink. So good job. Nobody let that thing can trick them into thinking it should be a different order. And our data flow diagram can be used to keep track of data passed among the various modules. Some of you that are in web dev, you might want to make yourself a website with some of these different diagrams. You know, what do they look like? We've seen flow charts, hierarchy charts. We added our data to our hierarchy charts, and now we have data flow diagrams from that. We've also seen IPO charts, the input process output charts that we did a couple of times, and probably a few others thrown in there. When you get into some of the other classes, there will be lots more, you know, NAT charts, organizational charts, all of the different kinds of charts and diagrams that we use in the CIS field. And it can be best to keep track of them in a visual way. So if you have a website or even want to keep a bunch of links to different examples so that you could review what each of the different kinds of charts is, that's a great idea. Now, here's this one. This one is where we really want to get clear on stuff. A call statement that passes values to a subprogram contains the subprogram's name and, in parentheses, a list of arguments. So when we call, all of the things in our parentheses are arguments. When we are actually declaring our function, all of the things in parentheses are parameters. Arguments go to parameters. Here's another one. We had our dress up. We have in our call statement, we're passing sandals, turtlenecks, and jeans. And in our declaration of our function, we're receiving shoes, shirt, and pants. So it looks like we have them in the right order for this one. The arguments are in our call statement. So that can be really confusing. Call statement, arguments, declaring the function, parameters. Arguments get passed to the parameters. Good. We start getting to where part of the hardest part of our test is trying to interpret some of the pseudocode. I know that. So it can be very difficult. So try to weed through all the extra stuff here and just look at what's important. We have a main, we're declaring two variables, A and B. We set A to a value of 4 and B to a value of 20, and then we call math. Now our output right now should be B, which is 20, divided by 4 equals 20 divided by 4, or 5. But we have this call math. And in our math function, we declare num1 as ref. Whenever we declare a variable being passed as a parameter as ref, it's going to be passed by reference. That means that math is going to be working on the same variable in memory as the main variable. So when math messes with num1, which is our A variable, our A variable is going to be altered in our main. So let's see what it does. Oh, it sets num1 to 5. So now our output is going to say 20 divided by 5 equals 4 instead of 20 divided by 4 equals 5. So take a look at that one. Try to really understand what's going on there. This is a problem with us in Python that we can't try this in our code, but we'll be able to this week now that we're going to be working with arrays. So we'll get a really good example. Now just scrolling through. There was one other one that I wanted to find because it shows up in a lot of places. And most everybody got this one. If a variable is declared locally within a function and globally, it's treated as if it were two different variables and the local declaration takes precedence. So it's always the one closest to you that is used. So here's another one that got us with the arguments. Values of the arguments are assigned to the corresponding parameters. So write that down, put it in your brain. I think I got my whole college degree without ever knowing which ones were arguments and which ones were parameters, because I was always just like, that's dumb, they just get passed across. But it'll be so much easier for you if you remember and you know. So I always get those questions wrong. So the arguments are assigned to the parameters. Functions that come with the programming language are built-in functions. Programming languages that let you create functions are user-defined functions. There's one more I want to find. I'm not going to be able to find it. Okay, any of those, if you have questions about, just let me know.
Can you go to the one where it says declare motel as string?
Declare what?
Motel as string.
Motel?
Mm-hmm. It's about motel and do drop in and interstate
Oh, okay.
95.
Why did it do that? I think I can. Yeah, it's bringing up that. Saved it as a shortcut for me. Or no way. Okay, this one?
Mm-hmm.
All right, so let's see what's going on there. All
I'm
right,
sure it's something simple, and I'm sure you've already said it, but for whatever reason, this one makes me.
let's see. Given the following statement, what values will be passed to the parameters of the subprogram named vacation? Okay, so motel is a string, interstate is an integer. We're going to set our motel to do drop in and interstate to 95. So when we pass in, we'll be using do drop in and 95. So in our vacation, we should get do drop in and 95.
Right, and it's, the correct answer is this cannot be done.
Oh, and here's where our problem is. Good
Okay.
job. In Python again, we don't have to worry about what data type it is. But up here we said that interstate was an integer. And here in our header, we're saying that it's a string.
Oh,
So that's what it's mad about.
Okay.
So good job. Perfect. So I'm kind of giving you an early chance to see what the certification exams will be like. Because I think that if we didn't have to have the written exams at all, you guys just wrote Python programs, just be cruising right along. I want every once in a while for you to stop and think about what that code is that you're writing and what it's doing. Now in our tests, I think scores were good. Last semester, the semester before, I had somebody in here helping, and his wife was a math teacher, and he said in the math department, they figure if the average is around a 50%, then it was a really good test. Because remember, you know, 50 is, well, maybe no, the average was a C is what he said, not 50%. My bad. The average was a C. Because remember, C means average, right? So if we looked at a curve, we should see the majority of people getting a C, a few people getting an A, a few people getting an F. That's a standard curve. I think that programming is kind of the same way, that a C is a good grade for a written test like this. That's why for your programs, you know, I give you the points, because these written tests are where you're going to lose points. That's just how it works. So a C is a really, really good grade. Also, if you look at the certification tests that we take in the CIS department, we take Microsoft certification exams. So Microsoft has this whole series called the MTA series, Microsoft Technology Associates. And so people take those exams after C# 2 and the SQL class, and I think Web Dev 2, different classes that they have certification exams for. We don't have a certification exam for this class, but those Microsoft exams, the passing score is a 70%. So if you get a C, you passed. You know, that's what they want. Whenever I first started teaching, I taught PC maintenance, so like how to repair computers. And the A+ exam, that is the certification for PC maintenance, at that time, the passing score was like 52%. And still yet, they only had like, you know, I think the pass rate was like 8% or something.
Oh, yeah. Those are very low. Even I tried to take my first one, I did it, and I failed it by like 20 points.
Awful. Why? That's what they make their money on. Now with Microsoft, we like these MTA exams because Microsoft doesn't make their money off certification exams. They make their money off other stuff. CompTIA, that does the A+ exam and some of the other certification exams, that's what they make their money off of, is certification exams. So if people just went in there and passed, they wouldn't make any money. We need to make it really, really hard. But the MTA exams are not like that. They're really fair. They don't try to have trick questions or anything like that. But it is kind of like this, where it's like, wait, that's not like what we were looking at in the code. So I want you to get used to converting into those words. If you look at your grade, you'll see that it probably didn't hit your grade very hard, even if this thing wasn't the best. And some people got really, really good scores. So good job. Let's look at our next stuff. I'm going to get out of this, and you let me know if you've got any questions about any of them. 70% the average, so that's
Not too bad.
close. All right. So chapter 7, we're backing up a little bit in our textbook, looking at arrays. So I'm going to grab this PowerPoint that says Array Structures by Riley and look at this one first. I'm going to download it because it has, you know, some fancy PowerPointy things. I hate it when I do that. All right. Let's look at array structures. Also, too, I know you guys are all thinking about scheduling, which is great. And when you get into the next programming classes, whether you take C#1 or Java 1, whatever, remember for those languages, your instructor will cover the same concepts. What are the data types? How do you declare variables? How do you do basic interaction with the console? How do you do if statements? So you'll get a lot of opportunities to reinforce the same concepts. So I was telling Shirley up here before class started, it's important to remember that learning is a process. And some people get really, really confused about this point in the class because we're starting to talk about passing data to modules and returning data and some concepts that can be a little bit confusing. And those concepts will all be rediscussed in your other programming classes. It's not like if you don't get it now, you'll never get another chance. So it's all okay. I was kidding with her. I said, you know, I missed a whole bunch of 6th grade because I was really sick. So I missed all of the stuff on how the heart works. I've never known how the heart works, you know, all those ventricles and things, I don't know. But it never mattered because I'm not a doctor, so it was okay. So I've always been okay. But and you guys will always have another chance. And I'm here on Thursday, don't forget, from 10:30 to 1 or 1:30. So anything you want to come in and work on things and practice on stuff and just ask a question or two, please do, especially if you're getting confused or behind. Now, we're looking at arrays here. We've already looked at them a little bit. You guys have seen a little bit about arrays when we first started with our loops, and we put our big sheets all around the room, and you guys walked around and looked at all those different loops, and you saw some things that were looping through some lists. So you've seen it a little bit. It's not going to be a brand new thing. But what is an array? Bless you. An array is just a variable that holds a repeating element, repeating data. So it lets us save information more efficiently. And we have to allocate an array before it can be used. So let's look at some variables and some data. We could have a variable like PCT that has a value of 25. Age could be 5. We could have a string name that has a value of Joe. We could have a variable payment that has a value of 123.45. We could have a Boolean, right, is valid, and we could have a value of true in that Boolean. So we've seen all sorts of different variables that we could use and how we could set those variables. So what do we do if we want a whole collection of things? I want to keep track of more names than just Joe's. I'd like to keep track of a whole list of people. Well, I can do that in a collection or an array or a list, depending on what programming language I'm working with. So here we're getting started. The square brackets indicate to Python and to most programming languages that this variable is going to hold an array. So by saying name equal open close square brackets, I'm saying name is going to be a list. There's going to be a whole bunch of entries. Now, here is my name list. In my list, I have Joe and Bill and Tammy and Vera and Austin. But how do I know which one of those names I want to refer to? Well, whenever I have an array, each entry in my array is associated with a number, an index value. That index value is just an integer that's a pointer into our array. So we always start counting with 0 when we're doing indexes. So us programmers always start at 0. We never start at 1. If I look at Tammy here, the index entry for Tammy is 2. So if I was referring to the entry in the array that holds the value Tammy, it would be name square bracket 2. That would be referring to that particular entry. Notice name is the name of our array, and then 2 is the index value where Tammy is. Now, if we wanted to change her name, we could have a statement that said name index value 2 equals this new value, new name, and that would update that value in our array. So that index is really important because we use it to determine where we're looking in our array. Let's say we have an array of ages here. Now, in our list of ages, we have 16 and 45 and 29 and 24 and 14. So this is what that array looks like in memory. Right here, I have all of those ages. Each of those ages that's in that list is associated with an index value. So my age 16 is at index value 0, 45 is at index value 1, etc. So I can keep track of all of my entries by using those index values. Let's put in this little teeny bit of code. Let's open Visual Studio Code and just put that in. I like Visual Studio Code, but I swear every time it opens on this machine, my title bar or menu bar is up too high to see. And so I keep having a hard time. Just dyslexic that way. Okay, so I want to create a new file. And I want to save it. So I'm going to do File, Save As, and let's go find where we want to save it. And we said this was chapter 7. So I'm going to say chapter 7, age array. And I want this to be a Python file. Now I'm not going to do anything fancy in here. I just want to have this sample code. So in the sample, we have age equal 1, 45, 29, 24, and 14. Let's see if I can zoom in here. I know I got it to zoom in before. Yeah, not anymore. Okay, so what if I want to print, I got to convert it to a string, but I'm going to print the age at index position 4. Which one is that going to print? 0, 1, 2, 3, 4.
Oh, no, it starts at 0.
Start at 0. So let's run it. There it is. So our very last one. So what if we print out the length of our array, str, and then I want the length of the age array. And in our last chapter, we were using the len function to get the length of a string. We can use it to get the number of entries in an array too. So I'm going to run this. And now I get my entry 14, which is at index position 4, and the number 5. So let's keep that information in our heads, and I'm going to go back to the presentation. Let's print out these other 2 entries. Index position 0. So print it. I think I closed code. I don't know. I keep doing that. Dum dum. See if I can find my file I just created. Huh? Shh.
Oh, you can probably use Control-Shift-T to open it back up inside of that.
Control Shift P
T.
T.
It worked for me.
Where should I be? Let me go in here.
I figured out a way to put everything in this folder.
Did you? Yeah, it does it really nice. And then I messed something up. I did something dumb to it. I did something dumb to it. I got to get some of these closed. Okay, so what happens if you do the 0 index value? What happens if you do 5? What happens with 5?
Nothing.
Nothing? Does it break?
Yeah.
Do what?
The one you just minimized, try clicking that on. Did you just minimize the Visual Studio?
No, it's gone.
I don't know.
There it is.
Oh, yeah.
It's not gone.
Try clicking the file above the name of my class.
I've got it.
There you go.
That's just crazy. Okay, I'm just messing with everybody. If I print out, why can I do 5? I should be able to do 5, right? This length statement said the length of my array is 5. So I should be able to print out the one at index position 5. What happens if you do that? Does it go crazy?
Says I can't do that.
Right, that index is out of range. So when we're working with an array, because our index value starts at 0, our index value is 0 through 1 less than the length of our array. So since our array has 1, 2, 3, 4, 5 entries, the highest index we can use is 4. 0, 1, 2, 3, 4 gives us those 5 entries. So it'll go crazy if we go above that. All right, so working with our arrays, you had a test question about this also. Because an array is going to be held within one variable, it has to all be stored within contiguous memory. Contiguous meaning pieces of memory right beside each other, straight together, without anything else in between, which is no big deal for a little array like this, right? But what if I worked someplace where I had an array of 6 million employees? Now I'm really using some memory. So we need to always be remembering that an array requires contiguous.
So that means you couldn't do like 0 through 5. Like it has to be like individual numbers, correct?
For, I think
For
so.
like the age. Like so in the brackets I couldn't just say 0, 5, and it wouldn't represent 0 through 5. It would only be 0 and 5.
Right.
Okay.
Depending on how you were doing it. Mhm. Okay, so contiguous in memory, taking up all that space. Now, when we look at this picture here, remember that's our index value. And sometimes you might hear people refer to that as a subscript value, because that is an older term for that same thing. So this array shows us our index and our data value. You could always think about it that way, that we always have those things together. Okay, so this is an array with initialization. It just means that within our square brackets, we're supplying all the initial values we want in the array or in the list. So we want all these ages to be within our list when we first allocate it. We start out with the name of our array and all those values we want within square brackets, separated by commas. And those initial values determine the size of our array. Now with Python, we can add more things to our array even though the size has already been determined. With some programming languages, we can't, but with Python, we can. And then once we have our array created, if we want to access one of the entries, again, we just specify the name of our array followed by the index location of the entry that we want to access. So which one is going to get put in one age there?
24.
0, 1, 2, 3. Yep, 24. Agree. Now our one age variable is just going to hold one of those entries. We have our array name, our index pointer within our square brackets, and our one age now has our value. You got it right. Okay, here's another one where we want to update that entry in the array. So again, we have our array name followed by the pointer location within square brackets. After our equal sign, we have the new value, and our third entry, whoops, if we go back, would have the value 28. I didn't put that in there though. Okay, now sometimes it's very common for us to just need to check every entry in an array. We'll hear that terminology a lot, and you might hear somebody say, walk the array, or traverse the array, or loop through your array. Either way, they're saying set up some sort of looping mechanism so that you can look at all of the entries in your array. So here's our age array again. Down here, we have a visual. We have our age array, and then we have a for loop where we're printing our age out. Let's put that code in our little program that we're working on. See if I can find mine now. I'm not used to the blue thing. Okay, so I want to stop running because I'm still sitting here with this error. So I'm going to click stop. And I want to take out that print statement that caused the error. So I'll comment it out, maybe put something over here to the side. This one will cause runtime error. Now what I want to do is a for loop. So in our presentation it said we could say for a thing in age, we want to print a thing. So what this is going to do is our for loop is smart enough to know that after our in keyword, we have an array. And it says, oh, you want to do a for loop in an array. Okay, I'll just give you each entry in the array as I iterate through your array. And as I give you each entry in your array, I'll put it in a variable named a thing. Okay, so whatever I name that variable in my for loop is what I will refer to within my loop body. Let's see if we can run this now.
Okay.
There we go. So now we got our whole loop, all of our array entries out. Let's put some more comments in our code here. First of all, for this age array, we want to declare and initialize an array. And I'm going to put a list in parentheses because in Python it's a list. And then I want to print the entry at index position 4. And then I want to the next one, we printed the length of our array, which is the number of entries.
And it can be any, I've just been playing around, it can be anything, it doesn't have to be a thing. It could be.
Right, it can be anything.
Mhm.
So for loop using an array. So yeah, what Jackie's saying is we could change this to be anything. So this variable name here is just a variable name. So I could say for list item, and then I could print list item. So you just want to make that name something meaningful for the loop that you're using. If I run that, it should do the same thing. No, we don't have to just print that list item. We could add some more. Let's do age is, and then concatenate list item to that. And then if we run, we should see. Oops, I got to convert it to a string now. Notice it didn't care about being converted to a string until we added in that other string in our print, and then it did. There we go. Now we've got our message out.
So what's the difference between the plus and the comma then? Does the comma automatically convert it to
Mm-hmm. Yeah, and it's only a Python thing, so that's why I just kind of stay away from it. People get all used to it and then mad at me in C# when I tell them they can't do it. Get all mad at me. Where's all these stupid curly faces? It gets ugly. Okay, so that looks good. Oh, look at them. They're so cute. Do you see my animation? They're so cute. Look at my PowerPoint animation. Now, this animation is important. So I'm going to back up, not just because I spent, like 10 minutes on it or more. See if I got it all the way back. So when we're using this for loop, I want you to notice what's going on in this animation. Think about it. Whenever we go to the first entry in our for loop, we get that value 16 in our thing. We go to the next entry, we get the value 45. We go to the next entry, we get the value 29. I think you're getting it. We never know what our index value is.
Oh, those are the animations. I thought
Yeah,
my sleepy eye was
No,
driving.
it's very minimal animation because I don't want to, overwhelm you with excitement or anything.
No, I'm just so good. When you said animation, so I was looking for them, but I thought thinking, I was like, oh my
Okay,
God.
it's minimal. It's minimal. Yeah, and we want you to get all excited. It's the end of the day. So we're seeing that with our for loop, all we see in our code is the value, the data value of our array entry. We don't see that index. That doesn't matter unless it's something that we need, and then it matters. So here it is again. See, we're just not seeing it. All we're getting is that number that we're looking at, nothing else. So sometimes we might have to do our own looping or do our own counting if we want to know what count we are. Okay, so before we look at anything else, the syntax for the for loop. When we're using a for loop, we're going to have for item name in array name. For is our keyword. This is considered a for each loop because it's going to be executed once for each entry in the array. So that's our for each criteria. It ends with our colon, just like a regular for loop. In is required The middle entry is our variable name. And finally, at the end is the name of our array. Now, we had all those ages, but those ages don't mean much without a person. So we might keep parallel arrays. And parallel arrays are where we would have two arrays with different pieces of information that are related. So these two arrays, we have our age array and we have our name array. And now they're connected because we made them so.
So if you put in 4, would that be lost in 14?
Exactly.
Well, I'm
So we're-
sorry, excuse me.
No, you're fine. Oh, yes, but we're trying to keep our entries lined up here. So Vera is 24. New name is 29. Bill is 45. Joe is 16. And that's just because sometimes in our code, it's pretty easy for us to manipulate these two arrays and keep them in order and keep them all together. So that's what we do with our parallel arrays. Keep two in order. So as we process them, we'll just always be looking at the group. Parallel. So in Python, arrays are not really built in. We use Python lists instead, but things work pretty much the same. So our lists or arrays let us keep repeating data elements. We can efficiently handle our arrays using for loops. And our for each version of the for loop lets us loop through all the entries really easy. So let's make some practice programs. We've got our one here that we were working on. We've got some comments on it. That's pretty good. None of you guys went to the advising fair today to see Dr. Ford, did you?
Yeah.
Did you? Oh, good, because you're one of the
Oh,
people.
I didn't get a chance to see her though because I was running out of time all week.
Oh.
So I had to come here.
So you tried. In our textbook, let's look at one of the examples that they have. And in chapter 7, as you take a look at it, you'll see that it's very, very short. Talks about lists and tables and talks about some lists of ingredients, how to enter items into an array, which we haven't done because so far we just created an array that had initial values. So let's write this program in Python together. So in this program, what we're going to do is have an array that is going to eventually have 12 entries, one for each month. We're going to keep a sum and an average. And what we're going to do is for 12 times, we might compress this down a little bit. We're going to ask the user to enter rainfall for the month and then give them a month number. We're going to read in the rainfall for the month and add it to the rainfall for the year so that we can output all our rainfall. Now this pseudocode, if you notice, doesn't have any functions. So we're just going to put everything in our main. So it's going to be ugly. Let's do it. Now I want to find Visual Studio Code and I want to create a new file. And I want to save it. And I'm going to make this one chapter 7, rainfall array. Now we have this ugly pseudocode. So let's see if we can kind of go back and forth. I'm going to go ahead and declare all the variables. the way they do. Let's get some comments here first. This script we'll call rainfall amounts. So our purpose, we're going to say, is to record rainfall amounts for 12 months. I'm having a really hard time doing this without functions, so we're not going to. Let's create a function ourselves because we can do better than the book, don't you think? You can still refer to it as an example. But let's define a function for our input rain. And, oops, let me save this again. I didn't tell it was Python. But something's acting weird. That's better. So in our input, let's just get a value to return to our caller. And this is going to be, what do we want? Do we want integers? We'll try it. Let's say this is going to be an integer. And our message, our prompt is going to say, enter rainfall for month plus, and they use K is a month. That's glorious. Let's do it. Now that means we need K passed to us in our input rain function, because if we're going to display that, we need to know what it is. So I've got to put it in my parentheses. I need now to be passed a parameter, and I'm going to name it K. That should be all we need for our input. So I'll just make our main, then call our input. Now, in our main, we want to declare these variables that we're going to use. We have, first of all, our rain array. And I think with Python, how do we declare an empty array? It's kind of weird. We have to actually do rain equal our open and close brackets. So in the presentation, I might have said rain followed by the open and close brackets, but it's actually a little bit weirder. You have to say rain equals an empty array. And then it says, oh, okay, you want this to be a list. Now our other variables that we're going to use in our program, sum will start out as 0. Average will start out with a value of 0. And then K I guess we'll just use K in our for loop. All right. So we're going to say this variable K is going to control our for loop, and we want to run this for loop in the range 0 through 12.
What do the little squigglies mean? How about in the code when it does that? Is that trying to?
Yeah, it's telling you that there's an error. So what does it not like about my for loop?
Sometimes it just randomly does it because I have the exact same thing and it's not on mine.
Oh, really? Because I'm like, I think that's right. Okay, then I'm going to leave it and we'll see what happens. So in our for loop, we're going to be collecting data for every month. So first thing that we want to do is prompt our user. So for our rainfall amount, so our rain array, because it's an array, Python is going to give us all sorts of functions that we can use with our array when we type a dot after the name of our array. So if you look through this list using Visual Studio.code, you should be able to use your wheel on your mouse to scroll through that list, or you could use your arrow keys. But all of these are the functions that are available in working with arrays. Well, since I want to add a new entry to my array, I'm going to use the append function. So what do I want to append to array? Well, I want to append whatever they type in my input rain function. It's all mad at me about this for loop. I got to fix things.
Mine's not giving me
Probably have to delete it all and put it back down.
Well, it wants me to declare this K.
Are we supposed to be trying to run it right now and see how it works?
You
for
can
us?
try, yeah, see what yours does. Mine is really mad at me.
Mine is too. Mine doesn't like line 14 at all.
Get rid of the parentheses surrounding the entire for condition.
The whole
Yeah,
parentheses.
those.
Oh, I'm C-sharping.
Okay.
Oh, no.
With this?
Mine is screaming at me.
What's yours screaming at you about?
Multiple things. Yeah.
Here, I'll stop the share and you can take over if you want.
All right.
Let's see what we got.
You can show.
Okay.
He's got it though. That's what we need.
I'm on train then. So people can see what I did wrong. All right. Let's go. Sure. Okay, sure. There's all its screens.
I think just put a space after your variable names before the equal signs. And
Right,
it might just be,
right there.
And if you mouse over them, is it just complaining that you're not using them anywhere yet?
Unused variable.
Unused variable. So the yellow is okay. It's just a warning. What about the red under the rain? That's one that's bad. If you mouse over it down there, down below,
Oh, right here.
in your rain.append, is it red?
says it's not defined, undefined variable, but I defined it right.
You also have to just have a space after the equals.
After the equals?
I thought I was just told to do that.
She didn't indent the for in the domain, so
Okay.
the for is coming before the main. I'm not saying.
And
Now it's happy.
is it?
Yep, good. So watch those with Visual Studio Code. Go ahead and release that. I got it. So when you're using Visual Studio Code, if you have a typo that it can't handle at all, you'll see that red squiggly line underneath it. Notice I'm not getting the yellow squigglies because I gave these initial values. If I take off the equals 0, I get the yellow squiggly warning. So just watch those because it's telling you that you've got an error. Okay, so is everybody okay?
No, I still got 3. I got 3 errors.
You guys okay back there? Got it all right? Did you see it? Do you want to remote?
No, I had it there and it didn't like it. It had the squiggly on it. And that's what it did. It doesn't like it. And then I tried it out.
Oh,
Squiggle. Oh, because I got rid of one and not the other. Okay, now it doesn't like the input rate. Or the sum, or the average. It doesn't like.
Just doesn't like you at all.
It's really mad at me. There's squigglies everywhere.
Did you get on the Zoom session?
No.
Okay. Well, we can't help her then.
No, it's okay.
Okay, so let's see what else we're going to do. When we read in a rainfall amount, we're adding it to our array, and then we want to add it to our sum. So sum plus equal rain at position K. Now, notice how we have our K used in a couple of different ways. First of all, in our append statement, we're adding an entry to the array. And we're passing K as an argument to append, or I'm sorry, to our input rain. Now on the next line, we're adding the value of rain at index position K to our sum. In this case, K is an index, so that's why it's surrounded by square brackets. Up above, it's an argument, so that's why it's in parentheses. So as we get into more advanced programming, some of these special characters that we have to use to surround some of our variables can be really confusing if we don't understand why we're using the value that we are. So anytime we call a function and we're passing arguments, we're going to be using parentheses. And that's because append is a function also. So we're using parentheses to pass it its parameter, which is what we want to add to the array. It's adding on, exactly. Okay, so now we got a new rainfall amount. We added it to our rain array, and we added it to our sum. But we added it to our sum using the value of K. All right. Now, once our for loop is over, we can calculate our average. So we'll say our average is going to be equal to our sum divided by 12, because we should have 12 months.
I've done that before. You look up and thinking and it's ooh, blah, blah, blah. Ooh. 12
Now for right now, let's print out the average monthly rainfall is, and then our average. Now you could go ahead, oops, and put in your call to your main and then try it. Do you really want to do 12 months though? I think I want to do 3. But if I change my 12 here, then my average isn't going to be right. So I think what I'm going to do is add a variable. And I'm going to make it be months. And I'm going to set it to 3. And then I'm going to use that variable to control my loop and to calculate my average. So how easy is it to change our for loop from using a number to using a variable? Super easy, just that easy, right? You just change it. So I still want to type in 12 rainfall amounts every time we run this. So I'm just going to be that lazy and make it be 3. Is it working? Let's try it. I'm going to try it here. Oop, it's mad at me. Must be string, not int. This is a, I'm going to stop running. This seems to be a Visual Studio Code dot thing. So what I found is if I don't convert it to an integer there, let's make it be 2 lines. So first I want to do the input statement. Oh, that's not going to work. What am I doing? Hang on. Thinking here, it's not helping.
I think it's mad at your k plus 1.
Do what?
I think it's mad at your k plus 1 as not being a string.
Yeah. You have that as
Oh, is it in the wrong place? Let's just try str, the whole thing. Is that the same? Mm-hmm.
so that to change the int to string, correct? At the top.
So what do you think? It's definitely Visual Studio Code is handling things a little different. So I guess we can just declare a variable. Or do we want this to be an integer? Do I not even need to convert it? I wanted it to be an integer and I tried to make it a string here and that wasn't any good. The integer gave us the same problem, right? Let me double check. So I went the wrong direction there. Yep, okay.
Yeah, it's the k plus 1.
Yes.
So I put the str format to k plus 1, and I got enter rainfall for month 1.
Oh, it's right here, just right here.
That's what I was talking about.
That's what he's trying to tell me. Good job, you guys. I've got it all figured out all the time. I just want you to figure it out. Like that. I still need a closing parenthesis. Now notice that one too. If I'm missing that closing parenthesis, notice the little red squiggly above the D on the next line. That kind of is an indicator that something wasn't closed right above that. So I'm missing a closing parenthesis. Is that all good?
You're gonna need that int back though.
I'm gonna want it to be an int.
Why you don't want it?
Mine doesn't have to be.
Yeah, it doesn't really matter at this point whether it is, but I bet when we get down to calculating our sum, it will. Let's try it. I'm going to do 3. Oh, I've already got, let's see, 3. Oh, there it crashed.
There. Yep.
Okay, so we've got to convert it to an int because we're trying to do this math stuff with it. Yeah. So I'm going to wrap the whole thing in an int. What's our rainfall? 4, 5, 6. Now I wanna add a space after that month number, and there's all these parentheses. So where should I put it? Should I put it just like right here after this first closing parenthesis, or after the second, or the third? How could I decide? My outermost parenthesis matches up with the int. My next one matches up with input. Then I've got my string and my k+1. So I think that's where I want it. You decide. I'm going to put that space there.
So why do you have an extra set of parentheses around the k+1?
Let's get rid of that extra set. It appears to be extra. How's that? Does that look right? Okay, that looks better. Now I've got a space after my month number. And I'll get out my rainfall amount. Awesome, that looks great. We're doing really good here. But before we print out that average, our users came back to us and they said, well, that's all great, but we would like you to print out each month first. So we decided that it would be best if we created a function to print out that rainfall array. So we're going to create that new function. Let's put it up here under our input function, and we'll call it print rain. Now for us to print that, we're going to have it passed to us as a parameter. I'm going to need my rain array. And then I know that I can use that for each loop and just say for each item in rain array, I want to print rainfall amount plus that item. Does that work? Let's run it. Oh, we got to call that. We haven't called our function. I'm going to call it right after we calculate our average. We'll do print rain, and we need to give it our rain array as an argument. Does it work? Okay, here's my prompt. I'm going to do 3, 4, 5. And then it prints out rainfall amount 3, 4, 5. So that's good. But they're still not happy.
Filthy.
They're still not happy. They would like it to actually print out the name of the month. Oh, can you believe it? Can you believe it? So let's get started by saying, how can we print out the month number first? In our for each loop, we're not using any sort of counter to know what month number we're on. So should we change our for each loop to be just a regular for loop like this one? Or should we set up a separate counter? Let's set up a separate counter. Let's. And then that way we can use it. So we'll say count equals 0. And then in our print statement, let's add rainfall amount for month. And then we want to do str count. And I guess just like down here, we should do count +1, or else we're going to start it at 0. That would be confusing to our users. So let's see how that looks. Now I've got 3, 4, 5. And now we've got 13, 14, and 15. Well, first I need a space. In between our count and our item. And then I want to know, how come my month keeps staying 1? What should I do to it?
You need to decrease things.
Add
Yes,
1 to it. She knew it. She wouldn't say it. You should have. So count plus equal 1 to add 1 to it. Now that should give us a good number.
So I'm just. Stop being a sissy.
I have a question.
Mhm.
With that for loop item in rain array, I'm confused on how it's working. So is item pointing to the index and then automatically getting converted to what is in that spot in the index? Because when we're printing it, wouldn't it print 0, 1, 2? Because that's for the index in that array.
Right, and since we're using a for each loop, we don't know what the index is. It's just giving us the data value. So it's never concerned with the index. It's just giving us back the item number that's in that spot of the array.
If we did in range,
Then we could loop through it ourselves and control it. So either way.
Did you make an array for the names of the month? I know we want to go.
No, but that's what we should do. That's what you guys should do.
I'm just saying for like month 1, it could be
Yeah.
January, like we did.
So I want you to try to do that on your own now. We have about 20 minutes. No, it's not because you asked. I was going here. It's not because you asked. So in your print range function, you need to create an array that has the month names and make them the 3-letter names. You don't need to make them the long names. But let's create a month array. And then I want you to add that month name printed out here instead of that number. So you've got about 20 minutes to start thinking about it, see what you can do. You can work together or on your own, whichever you would rather do. But I know you guys do better if you're trying to figure it out on your own than if I'm showing you. I think you do. But you figure
Do you mind? I don't know if you.
do it.
I was gonna ask if you could leave that up for just a second.
Sure.
Finish copying of the Week13.